So let's see these different testing techniques. So before we start seeing different testing techniques, we'll see about confidence level. What is this confidence level in this hypothesis testing? So in confidence level, see, we are using parametric or non-parametric testing techniques to test whether the hypothesis made is valid or invalid. Somebody had made a comment on H naught that it is equal to 500 ml. So, and we are saying that we are trying to test it using some testing technique, whether it is true or false, right? When you make a claim, suppose you are using t-test, for example, you used t-testing technique and you have proven that H naught is rejected. H naught is rejected. It means the amount of Coke available in the bottles by Coca-Cola company is not 500. You proved it. Okay. But how much confident you are about this? That is confidence level. So whenever you use these hypothesis testing techniques, we generally also give your result. You will say H naught is rejected at some percentage of confidence, right? Because the data which you have taken, again we are talking about population, right? Population is there, you are randomly taking a small sample. Using the samples information, you are making a claim like this. You are proving or disproving a claim like this, right? Maybe the sample which you have taken is only the sample which has negative information, or maybe which is making you to prove that it is not equal to 500. Okay, there is a chance that whatever claim you are making using this samples information is not the accurate data. Suppose it contains, there are 100 bottles, 100 Coke bottles are there. And in the 100 Coke bottles, 95 are having exactly 500 ml. Okay, 5 are having maybe 495 ml. And company is saying that it is 500. You want to prove it is not 500. Okay, you are randomly picking a sample from that 100 bottles. You are taking only five bottles. By chance, whatever five bottles you have chosen, if they are from this 95, then you will say that no, yes, whatever claim made by company is true. Yes, because you when you take randomly five, you calculated their average, it is 500 only. You failed. So you will say whatever company has said is true. Okay, right. So that case, you have to be you have to use a parameter called confidence level. It is called as a level of significance also. Confidence level, significance level, level of significance. These are terms very frequently used. So standard we use 95%. Okay, level of significance or confidence level is represented using alpha, and this value is 0.05 in 100. Okay, we use this 0.05. Okay, alpha as your 0.05 value. It means 95%. Alpha value is 1 to 0. It is between 0 to 1. In that, 0.05 is your level of significance. By default, that is the standard. So we say whenever you are trying to make a comment about H naught or H1, H naught again, exactly it is H naught. You are trying to prove or disprove whether it is equal to or not equal to. You will say that H naught is rejected at 95% confidence level. This is nothing but the probability of the error. There is some error percentage, right? Because there can be chances that some error you have done during calculation, or you might have taken some wrong data, or the data which you have taken is not proper. So there is chance of little error in the document, in the data what you are having. That's why this is nothing but the probability of the of having error in your proof. There is a chance that might be I did not use much nice data, or I have used only one or two samples. I could have used more number of samples. So that is your confidence. level. So when you are applying any kind of testing technique like T, Z or F testing, you will say that my result is at a confidence level of 95%, or sometimes specifically they will give that percentage in question itself, that identify whether the H naught or the comment given by the salesperson is true or not at 97.5% confidence. Sometimes they will say like this. So accordingly we have to solve our problem. When we solve problem, we will try to understand. Now let's try to go back on these two different testing techniques. In parametric, we had T, Z, and F. These two are of one category. This is of different category. These two are mainly used to comment about population and samples data. So here F test is only used between two populations. F test is used between two populations, whereas T and Z test are used between a sample and a population. Okay, it means T and Z can be applied when there is a population P. You have taken a small sample. Yes, you are using this samples data. You are making a claim. This sample belongs to this population. So when you want to make a claim H naught using the samples data, and you want to prove whether the comment made by me is true or false, then you apply T or Z. So this is a fight between a population and a samples data. F test can be applied between two populations or two samples. Okay, so from a population, I may take a sample S1, another sample S2. So I want to comment about these two samples, how they are related to each other. What is the variance between these two samples? How is the data available in both those samples? That is given by your F test. So we'll try to, again, there is a category. T and Z are about population and sample. F is about either population or either samples. So we'll talk about T test and Z test first. T test and Z test. You know the different parameters of population and sample. Mu, X bar, this is about population, this is about sample. Here it is standard deviation, here it is of sample. Here it is capital N, here it is small n. Okay, so these belong to population and these belong to sample. Now, T test is defined as T equal to X bar minus mu by sigma X bar by square root of n. Okay, Z test is given by X bar minus mu by sigma by square root of n. Okay, so this is the formula for finding out the T value. We are trying to find out a T value. X bar minus mu by standard deviation of X bar by square root of n. This is not required. I guess here also this is not required because that is derived from central limit theorem. Just a second. Yeah. So this is the formula. Here, see, by this you can clearly say, we applied T test. We applied. So this is the standard deviation, right? This is the standard deviation of population. This is the standard deviation of sample. If standard deviation of population is unknown, we go for T test. If standard deviation of population is known, then you go for Z test. Okay, both are same test. Only difference is that for T test, we can apply T test when you don't know the standard deviation. When you don't know the standard deviation value of the population, you apply T test. When you know the standard deviation of the population, then you apply Z test. Sir, now you may ask me one question. The problem given to me, I know the standard deviation of population. It is given. All these 6 information is given. These three about population and these three about sample are given. All six information is given. Now which one should I choose? Because both are same test. Which one should I choose? In such case, t-test is applicable for samples less than 30. Typically, we apply t-test for samples of size less than 30. Z-test is applicable for samples greater than 30. Okay, so t-test is generally applicable for less than 30 and z-test you can apply for greater than or equal to 30. So in the given problem, maybe once you see a small problem, only you will get more confidence about this, what I am teaching here, what is t-test, what is z-test, how do we calculate it. Okay, so these are the population parameters, these are sample parameters. From the given problem, you will see whether the standard deviation of the population is known or unknown. If it is unknown, apply t-test. If it is known, apply z-test. If it is known, still you are confused, you can apply t-test for the sample size less than 30. You can apply z-test for sample which is greater than or equal to 30. Right, so this is little about t-test and z-test. Let us solve some problem in t-test and z-test, then we'll come back to f-test so that you understand it much better. So yeah, so I have a small problem here. Try to read this, let's see what it is telling. Please read this, I think it is visible, you can read this. Right. So see what's the data given to us. A teacher claims that the mean score of students in his class is greater than 82. A teacher is claiming. So you have to define your H naught, null hypothesis. H naught is the average score. The mean score is greater than 82 with the standard deviation of 20. So this is see the mean score of students. It means the whole population. They did not say about small. In a whole class, they said it. Okay, so that we don't know what is the count of the class, and the standard deviation is given. It means population's data is given to us. Population's data standard deviation is given as 20. If a sample of 81 students was selected, it means sample n size is 81 is selected. Then the mean is found to be 90. Then the mean is found to be 90. Then check if there is an enough evidence to support this claim at 0.05 significance level. So what is the teacher making a claim? It is saying that the mean score of students in his class is greater than 82 with standard deviation 20. So that already we have. So that mu is given as 82. If the sample of 81 was selected, randomly I am taking a small sample, the mean is 90. So whether this claim is true or false. See, maybe they are telling we are taking a small sample of 81. Maybe this data what they are having is about 200 students, assume of 200 students. Teacher is saying that we don't know that n value. I'm just giving an example. Maybe for out of 200, 250 students, the average marks is greater than 82. She is telling that. Teacher is making a claim. 82 for maybe 200 to 50 students. I am taking a small sample. For that I calculated average. I found it is 90. So whatever the teacher is making, is it true or false? Is there any check? If there is enough evidence to support this claim at 95% significance level? 0.05 means 95% significance level. So what your H naught is mean score greater than 82. What is your H1 here? Mean score not 82. It means not greater than. It is not greater than 82. Only that way. It is greater than or not greater than. Only two claims. Yes or no cases. Now which test to apply? Which test to apply? If you see the standard deviation of the population is known. The standard deviation of population is known and the sample size is greater than 30. So you have to go for Z test. You have to apply Z test here. So what is your Z test formula? Z test says that X bar minus mu by standard deviation of population. So what is X bar value? It is 90 minus mu value here is 82 by 20. I think this is right. By 20, here also we have to use square root of n. So this, if you calculate this z value, it is somewhere around, I can directly calculate and tell you, it is 3.6. It is 3.6. Z value is 3.6. So we got Z value as 3.6. N value is 81 here. So square root of 81 is 9. So it goes up. So 8 into 9 by 20, if you calculate it is 3.6. So after solving this, I got Z value is 3.6. I know my H naught, that is greater than 82. H1, that is not greater than 82. Not equal to, but it is not greater than. Not greater than 82. Now, when you have this Z, how to make a comment? For this, we have to use statistical tables. Okay, I will show you about statistical tables, how to use that. But generally, so here the claim is at 0.05%. Okay, so we will have to use the statistical tables. I will try to share that 1 second. I'll share my entire screen. So you should be able to see. Yes. So this is one table, and maybe I'll zoom it out. So we have statistical tables like this. Okay, we have statistical tables. This document is available in the internet. I can share it with you. So which has all the table informations. Okay, so you have see this is T table. This is for T. So we have to go. This is for F. This also for F. This is Z table. Yes, we got this Z table. I'm zooming it nicely. Yeah, this should be visible for you. So right. Now, how do we use this Z table for this problem here? We got Z values 3.6. Okay. Now, what you have to find here, we have to, there is one word, confidence level, right? Significance level at 95% or 0.05%, right? Significance level. So go to Z table here for 0.05, for 0.05, right? You have to find it. This is actually table is not complete. I guess I should have another table. T, just a second. Z table. Z table. This is the one. Okay, it's missing somewhere. I will show you this how to find it out. Right here, a table that Z is not completely, but generally we have to see it this way. So for 0.05 significance and this degree of freedom, actually this is degree of freedom. For that, what is the value you have to calculate? So I will directly solve this here now. Maybe for another problem I'll show you. So at 95% or 0.05 significance level, the Z table value is 1.96. Z table value is 1.96. Okay, so now what you calculated, Z calculated is 3.6, right? So whenever the Z calculated value is greater than Z table value, whenever the Z value you calculated is greater than the table value, in that case, H naught is rejected. H naught is rejected. Okay, we say that H naught cannot be accepted. The claim made here is incorrect, right? So one more problem, maybe you understand it better. Yeah, this can you read this problem? We will try to solve this. So this is one kind of problem. Please read this. A visual research lab has purchased a digital color blindness test from a company. Before they can use the test in their research, they must ensure that it is properly calibrated. To do this, they must check that they get the same results as the company when testing participants with no color deficiencies. The company states that participants with healthy color vision will score 15 on average. The research lab tested 13 participants and they found that for 12 it is 3.6. Okay, let me explain this with the numerical data. What they are telling is they have purchased an equipment, whether it is, so they want to, before they want to use in the research, they want to test whether this equipment which we have got will it work properly or not. Okay, so is the machine properly calibrated or not? So what information did they give? So the company states that the participants with healthy color vision will score 15 on an average. So their H naught says that score is 15. Obviously H1 will be not equal to 15. The research lab test 13 participants with healthy color vision. So see, they are testing only for a small set of number. There's testing for a small test of number. So the sample n value is 13. Company is saying for people with healthy color vision, score will be 15. These people, they are taking 13 participants data. That is 13 people's data they are taking. And on average, they score 12. So there here they are scoring the value as 12. So the average value here is 12. And for the population's data, the average is given as 15. Here it is 12 with the standard deviation 3.6. So the standard deviation of the sample is given as 3.6. So population standard deviation we don't know. Okay. Now which test we have to apply? Obviously it is t-test. We have to apply t-test for this. So how do you calculate t value? If you find out t, let me erase this h naught. Maybe we can do it here. So t value is nothing but x bar minus mu by sigma x. So this is 12 minus 15 by standard deviation, that is 3.6. So I think if you calculate this by sample size, that is square root of n 13. If you calculate this is around minus 3.0046. How to calculate t value? I'll explain once again. You are just substituting these values. So t equation is x bar minus mu by sigma x bar by square root of n. So x bar value is 12. 12 minus mu value is 15. 15 by a standard deviation of sample is 3.6. 3.6 divided by square root of n, that is sample size square root of 13. It goes up. So if you multiply this with square root of 13, then you get minus 3.0046. Okay. Did they talk anything about confidence level here? No. They did not mention anything about confidence interval. It means by default it is 95% confidence interval. And what is the degree of freedom here? Sample size is 13. So degree of freedom df is n minus 1 always. So n minus 1, 13 minus 1, 12. So at 95% confidence level, at a 12 degree of freedom, what is the t table value? Let us go and see t table. We'll go for t table. Yeah. So t table is given to us. So degree of freedom is number of sample minus 1. Sample size is 13, minus 1 is 12. So this line I have to see. Sorry, this line. In this, what is the significance level? I will talk about one tail, two tail, but now we are talking about one tail test. So it is 95% means 5%. Okay, 95% means it is 5%. So 1.782 is the table value. 1.782 is the table value. From this you can see this is the table value. This particular one is the table value. So now I will go here. So the T calculated is -3, T table is 1.7. So T calculated is greater than T table, right? When it is greater than, when you get negative value, we have to ignore the sign. When you get negative value, you have to ignore the sign. So this is greater than T table, therefore I will reject H naught is rejected. It means when H naught is rejected, the claim made by the company that the number of participants will score 15 on average is false. Whatever claim they made is false, right? So maybe one more case we'll see where H naught is accepted. Yeah, Sarah problem. Yes, this question, I think it is visible. Try to read this question, try to understand this. We'll try to solve this and see whether the claim made by Sarah, a psychology student, it is true or false. I believe it is visible. If not, I can zoom it for you. Yes, this is the problem. Please read it. A psychology student, Sarah, is giving out sleep diaries to her university friends to monitor number of hours of sleep they have each night. Sarah believes that university students sleep for 6 hours per night on average. Below is the data that they have collected. The number of hours sleep per night for each student was average over a 1 month monitoring period. Is there any evidence to suggest that Sarah's belief is incorrect? So what she is telling, Sarah believes that university students sleep for 6 hours per night on average. So do they really sleep for 6 hours per night or not is the problem. So let us come to our, oh sorry. Yeah. So let us see what is the data given to us for this problem. So it is clear that H naught is average sleep duration is equal to 6 hours. Obviously H1 will be not equal to 6 hours. So below is the data they have collected. The number of hours, sleep hours per night for each student was average over a 1 month monitoring period. So this is a sample now, because this is a bold statement that average hours is 6, not of a particular month or a year. Generally, she told it is 6 hours. So we have 1 month data here of 8 people. Okay, from this, this is a sample data. Definitely, it is a sample data because participants is 10 only. From this, you find out what are the values. You have to calculate mean, that is average of these hours of sleep. Then you have to find out standard deviation. Obviously, we are not given the standard deviation of population, right? So only samples data is given to us. So I will just quickly write these numbers for you. X bar. So X bar here is the average hours of sleep for this sample. So if you calculate, it is around X bar is 6.31. 6.31. From this table, I calculated it. You take average of this 10 value, you get 6.31. If you calculate standard deviation also using the formula, you get something around 1.208. So from this data, you have calculated X bar, sigma X. And you know, the population's average, that is mu, is 6 hours. And we are not given the standard deviation of population. So which test to apply? Obviously, it is t test. So X bar minus mu by sigma x bar by square root of sample. So what is x bar value? 6.31 minus 6 is 0.31 into this square root of n will go on top. So the square root of 13. No, 10, right? 10 people of sample size is 10. 10 by sigma x bar, that is 1.2, 1.208. So if you calculate this t value, it is somewhere around 0.811, 0.8115. Okay. So the t calculated value, t calculated by this equation is 0.8115. T calculated is 0.8115. Nothing is given about the confidence level. So it is by default 95%. By default it is 95%. So let's go to table. What is the degree of freedom here? Sample size is 10. It means degree of freedom will be sample size minus 1, that is n minus 1, 9. So for 9 people, for a degree of freedom 9 and 95%, what is the t table value? Let's go to table and see. If you see here, t table at 95% confidence interval, and for 9 it is 1.333. 1.833. I think you can see from here that for degree of freedom as 9, and for 5% confidence interval, it is 1.833. So I'll come back here. This is 1.833. In this case, t calculated is less than t table value. Therefore, H naught is accepted. Okay, why it is accepted? Because the t calculated value by the equation with the formula is less than the t table value. Then we say H naught is accepted. It means Sarah's claim that the university student sleep for 6 hours per night average is true at 95% confidence interval, or 95% confidence. I can say that. Right? So this is about t test and z test problems, how we try to solve t and z test. Okay. Next, now I think we can, I will talk about one tail, two tail test once. I will give an idea about one tail, two tail. What is this one tail test and two tail test? Because when you go to this tables, you can see there two tail test and one tail test. Okay, when you have to take, which one you have to consider? Do we have to consider what is this case, one tail and two tail? So in all these parametric testing techniques, we are talking about H naught and H1. H naught, it is equal to 500 ml. H1, it has three cases. One is not equal to 500 ml. Second case is greater than 500 or less than 500. So there are two cases in H1, greater than 500 or less than 500. Okay. So when it is to prove that given statement is equal to 500, when you want to prove that it is just not equal to, it is one tail test. When you want to prove that it is just equal to 500, it is one tail test. And when you want to prove it is greater than or less than, it can be greater than or less than. You don't want to give this statement. You want to give comment about this greater than or 500, less than 500. In that case, you have to apply two tail test. So when you go to statistical tables here, you have to consider data of two tail test. So a two tail test, 5% interval is here. So your 9 value will be this, something like this. Okay. So if it is to prove that it is only not equal to one tail test, if you have to prove about greater than less than two tail. Why it is called two tail, one tail? I will tell you one thing. Generally in probability distributions, we have not seen probability, but the data is normally distributed like this. This has to be center. So something normally distributed like this. Your data is distributed like this. So you are making some claim at 5%, no error rate 5%. So this is your 5% error rate. You are leaving it 5%. Right. So if you are making this, see it only first half, see only this half. If you observe only this half, this side, you are 95% sure this is 5%. Okay, this is one tail. Two tail means you are checking both the directions, whether it is less than 500 or greater than 500. So in that case, you will consider this part also. So in that case, your 95 will be something here. You will complete, you will consider the full data. So here you will not consider 5. You will consider here 2.5% data. Here you will consider 2.5% data. So this will be your 95%. This point you may understand when you go for distributions. In probability distributions, you will understand that. Just to give an intro, I have introduced here. So when it is a two-tailed test, you are checking at both the ends, this end and this end. So your error rate is 5%, means 2.5 this side, 2.5 this side. If it is one tail, you are not checking the other end, you are checking only one end, because you are focusing only on equal to or not equal to. So in that case, this will be your 5%, this will be a 95%. Okay. Naming convention has come from this, that it is two tail and one tail test. Okay. So I believe you understood about two tail and one tail test and degree of freedom what we are seeing, and this is the significance level. If it is 95% significance level, this is the value. If it is 97.5, this is the value. If it is 99%, this one. 99.5%, it is this. 99.9%, and so on. That way you can use this T table, Z table, or F test, F table. Now let's go and see about the third test, that is F test. Okay, what is this F test? I said you T and Z are to play between one sample and a population. Somebody is making a claim about a sample, and we are trying to, and also he is using a sample's data, he is making a claim on population data. We are trying to prove it or disprove it. You are making whether it is true or false, you are trying to do that. Whereas in F test, okay, in F test, we use this between two different samples, Okay, how to calculate this? Between two different sample or two different populations as well. Okay, how do you calculate this? So the equation for F is nothing but S1 square by S2 square. So you have two sample S1 and S2. You know their variances. You know the variance of S1, you know variance of S2. Just divide it, S1 square by S2 square. You get a number here. That is F calculated. Okay, so let us understand this with the population and the samples example. First case, let's take sample. So you had a population P. Okay, so this population P is about heights of students. You are randomly drawing two samples, sample S1, sample S2. You are drawing a sample S1 of 12 students, and you find out that the average height is maybe 166 centimeters. You have taken another sample of 15 students of different size, and you find out that the average is around 167 centimeters. Assume, for example. Okay, so you have taken two samples, 12 and 15, and this is the results. Now, what is the F test is used to find out whether the variances of these two samples are equal or not. Whether the variances of two samples or variances, again, to be more specific, the parameter parameter of two samples are equal or not. What can be parameters? Mean and standard deviation. So mean height of 12 students, you find out. Maybe mean of 12 students you find out, and mean of these students you find out. Are they equal or not? What is the relationship between the parameters of both these sample? How are these two samples related to each other? Okay, so F test is used to test the equality of the parameters of both the samples, which can be of different size or same size, because randomly we are picking samples, right? Randomly we are taking samples. So there can be different elements or same elements sometimes. some at least some similar elements. So to comment about their equality, that these two samples which I have taken for doing some analysis, they are equal irrespective of the number of count of elements in the sample. For that, we use F test. You will understand this much better with a numerical example, like we have already seen few problems for T and Z test. So how is this given? F test. F test is given by standard deviation of variance of sample 1 divided by variance of sample 2. Okay, and it is always believed that the sample which has larger variance should be on top. Okay, so you have a sample S1 of size N1, you have sample of S2 of size N2, you have a sample of you have an variance of sample S1 is S1 square, here it is S2 square. Whichever is larger, that should come on top as numerator. So in this case, it is believed that this is greater than, always you have to take in this case. Now, degree of freedom in F test, we have two N1 and N2. Which one should I consider? Which one should I consider for degree of freedom? That case, you will take for S1, that is N1 minus 1, S2, it is N2 minus 2. N1 minus 1, yeah, true. N1 minus 1 and N2 minus 2. Correct? So this way you will calculate. Once you see F test, you will understand about this S1, S2. Degree of freedoms N1 minus 1, N2. Sorry. N1 minus 1, N2 minus 1. Not 2. Okay. So we will calculate F test. Similarly, once you calculate F calculated value, then you will go for F table value. You will calculate F table value and you will check whether F calculated is greater than or less than F table value. If F calculated is less than F table, we accept H naught. Otherwise, we reject H naught. Okay. So let me share one small example problem. What we have with us. Directly, I'll give the data. Let us solve it. There is one F test problem. So the information is given like this. You have sample S1, you have sample S2. It's a standard deviation. I'll come to that. We have N. Here it is 41. Here it is 21. This is 10.47. And here it is 8.12. So you have this data with you directly. Now, I am not talking in terms of a researcher has done this, found out this. Now you tell how their what is the equality between these two samples. So we have to apply S1 square by S2 square. So you already have your standard deviation. So this one is larger. So I will be taking here 10 point, I'll be calculating my F calculated value as S1 square, that is this square. So 10.47 whole square by S2 square, that is 8.12, 8.12 whole square. So if you find out this F calculated, it is somewhere around 1.66. Now, what is degree of freedom? Degree of freedom for S1 is N1 minus 1, that is 40. That is for N. Degree of freedom for sample 2, it is 21 minus 1, it is 20. So 40, 20 and this. Let's go to F table and see what it says. We had F tables here. So see, this is the F table at 5% significance level. It means 95% significance level. Right. So V1, V2, that is the degree of freedom. So for us, for V1, it is 40. V2, it is 40. 40 and V1, you can see for 20, 1.84. No, we don't have the table. Actually, it is less. We don't have this 40. I think some other table I will just check. Do we have for 5%? Yeah, here we can have, see, V1 is 40, that is sample 1, and V2 is 20. So what is the value here? 1.99, right? 1.99. So we got the F table value as 1.99. So here F table is 1.99. So if you see, F calculated is less than F table value. F calculated is less than F table value. Therefore, H naught is accepted. We did not define anything of H naught, H1. I just gave numbers directly. So H naught is accepted. This way we try to solve the apply parametric testing techniques in statistics. T test, Z test and F test. Okay. So somebody is asking about degree of freedom. See, this is also linked with confidence level or level of significance. Degree of freedom means, suppose the sample size in the previous problem, sample size of S1 was 41. I have taken degree of freedom of S1 as n1 minus 1, that is 40. It means I have freedom of this 40. This 40 variables can vary. I am making a statistical analysis here. When I am making a statistical analysis, this degree of freedom indicates that it is the number of values which can be used in final calculation, okay, which are free to vary. Means this numbers 40 can change. They are free to vary here. Okay, in your sample data, these 40 values are free to change when you're doing some analysis, right? That is degree of freedom, maybe in different uh, yes, this is different in different courses, but here it is, we reduce one and we say that out of 41 sample, 40 can change. 40 variables I'm considering for my work. So when we say 95% significance, or when we say 0.05 level of significance, we also consider this degree of freedom. Means not considering all the data points, considering 40 data points, and I'm making a claim. That's a standard procedure. They don't say take all 41 sample, take one less than the given number of sample size, and using that you try to make a claim. For that we give degree of freedom. So if we go, so we have seen these three different testing techniques only: T test, Z test and F test. So we have to study about chi-square test as well. So we will continue this in next session. I think you understood about these three different techniques. We have these three: T, Z and F test are parametric testing techniques, because the parameters related to population and sample are given to us. We apply this and you try to find out whether the hypothesis, null hypothesis made, is valid or invalid.